In this lesson, we'll be looking at the equation of a circle given the ends of the diameter. And if you're not subscribed to this channel, please subscribe and hit on the notification bell so that when a new video is being published, you're going to be the very first person to be notified. Now let's start. So first, we're going to look at the proof of the formula for finding the equation of a circle given the ends of the diameter. Then we apply the formula in solving practical examples. Now we are saying that we have a circle here, and this circle has a center. Let's call the center of the circle C. And there is a diameter which passes through the center of the circle. We know that this diameter has its ends. So the end here is made up of coordinates A, which has the points x1, y1. And then when you take the other end too, it's also made up of the coordinates B, which has the point x2, y2. Now, let's assume a point P on the circumference of the circle, which is also made up of the coordinates x, y. So from here, we are going to apply the idea of circle theorem to complete whatever we have here, which means that from circle theorem, it is said that the angle subtended by a diameter at the circumference of the circle is 90 degrees, which means that this diameter subtends an angle at the circumference of the circle, but the angle subtended at the circumference of the circle is 90 degrees. So this is what we have here. Now, this is what we can observe. We can see that the line AP is perpendicular to the line BP, which means that the line AP here, AP, is perpendicular to the line BP from what we can see. So if that's the case, then we can see that the gradient of the line, the gradient of AP being multiplied by the gradient of BP is equal to -1. So if the line AP is perpendicular to the line BP, that means that when you multiply their gradient, then we should get -1. So that is geometry. So it means that we have to find the gradient of AP and the gradient of BP, then we go to -1. So first, we tackle the gradient of AP. Now the gradient of AP, I think we have to continue here. So the gradient of AP, that is going to give us, so that is y minus y1. So you have y minus y1 divided by, here we have x minus x1. That is considering A and P. When we also consider B and P, which means you multiply, and their gradient here is y minus y2 divided by x minus x2. Now it's equal to -1. So we have to multiply, which means that y minus y1 multiplied by y minus y2 divided by x minus x1 multiplied by x minus x2 is equal to -1. So we cross multiply here. Now here it means that y minus y1 multiplied by y minus y2 is equal to negative of x minus x1 multiplied by x minus x2. So here what we are going to do is that we have to transpose the right hand side to the left hand side, then we go to 0, which means y minus y1 here multiplied by y minus y2 plus of x minus x1, and then we have here as x minus x2, which is equal to 0. So this is the proof of the formula for finding the equation of a circle given the ends of the diameter. So whenever there is a question and the question demands us to find the ends of the diameter given the coordinates of the ends of the diameter, then it means that we have to write this formula in solving the question given to us. So this is the formula that we'll be using in the practical examples we are going to look at. Now, let's look at these two examples. So we have example 1 here, and it says that find the equation of a circle with AB as diameter, where A has the coordinates -1, 3, and B has the coordinates 3, 2. So now let's look at how you can solve this. So solution, from the formula that we just proved, we said that given the ends of the diameter and want to find the equation of a circle, then the formula is giving us y minus y1 multiplied by y minus y2, and then it's plus of x minus x1 multiplied by x minus x2, which is equal to 0. So from what we have here, we just have to identify what our y1 and y2 is and x1 and x2 is. From the coordinate given to us, then we do direct substitution. So from here, we can see that when we take A, then means that our x1 is the first point and y1 becomes the next. When you take B, we have x2 here, and this becomes y2. So we are just going to do substitution in the formula, which means that y minus y1 here we know to be 3, and we have y minus, and y2 we know to be 2, so we write 2 plus now x, so we write our x here, minus x1 we know to be -1, so it means that I have -1 here, and then the next one becomes x minus, so x2 is 3, so we write our 3 here. Now we equate to 0, which means that we can simplify. So here we have y minus 3, y minus 2 here, plus x, so -1 gives us +1, and x minus 3, which is equal to 0. So what we are going to do is to expand, which means that we are going to multiply y minus 3 by y minus 2. So it means that when y multiplies y, we have y squared here, and I think we have to go up small. So when y multiplies y, we have y squared here, and when y multiplies -2, we have -2y. And then when -3 multiplies y, we have -3y. And when -3 multiplies -2, we have plus of 6. Then we come to the next bracket, that is plus x multiplies x gives us x squared. Now x multiplies -3, -3x, which means 1 multiplies x gives us plus x. And then 1 multiplies -3 gives us -3, and we equate everything to 0. So here we have to simplify, which means y squared minus 2y minus 3y gives us -5y. And then we have our plus 6 here. And then we have x squared. And then we can see -3x plus x gives us -2x. We have our -3 here, which is equal to 0. So we are going to rearrange just like the equation of a circle, which means that x squared comes first, followed by y squared, and then it follows to minus of 2x. Then we add our -5y, and we can see that we have plus 6 minus of 3, which is equal to 0. So at the end, we should have x squared plus y squared minus 2x minus 5y, and then 6 minus 3 gives us plus of 3, which is equal to 0. So the equation of a circle given the ends of the diameter now is x squared plus y squared minus 2x minus 5y plus 3, which is equal to 0. Now let's try example 2 of today's video, and that's going to be the last example. So we have example 2 here, and it says that the points m 3, -2 and n -5, 6 are the ends of a circle. Find the equation of the circle. If at this point you have not subscribed to Bakumat, kindly spend a moment and subscribe. And you can also pause the video and try your hands on it. Then later you can unpause it and watch the solution. Now let's solve. So you have been given the ends of the diameter, and we are saying that to find the equation of a circle given the ends of the diameter, then we are going to use the formula y minus y1 multiplied by y minus y2, and then we have here as plus of x minus x1, and then we have x minus x2, which is equal to 0. So from the coordinate given to us, we have m and n, which means that the first one for m becomes x1, the second one becomes y1. For n, here becomes x2, and then the next one for y becomes y2. So we have this, we just have to do substitution, which means we have y minus, our y1 here is negative 2, and then there is existing negative in the formula, so it means you have negative of 2 here. And then we have y minus, now y2 is known to be 6, so you have our 6 here, plus x minus, so x1 here is 3, so you have our 3. And then you have x minus x2 is known to be minus 5, which means there should be minus of 5 here. And then we close our brackets, which means that we have to equate everything here to 0. Now we can simplify the brackets before we expand. So you have y plus 2 here, and you have y minus 6 plus, so x minus 3, and then you have x plus 5, which is equal to 0. So what we are going to do next is to expand, and basically we are just going to multiply the bracket. So here we continue by writing y times y gives us y squared, so we have our y squared here, and we can see that y times minus 6 gives us minus 6y, and y multiplied by 2y gives us plus of 2y, and we can see that 2 multiplies minus 6 gives us minus of 12, plus, now x multiplies s gives us x squared. Now x multiplies 5 gives us plus of 5x, and we can see that minus 3 multiplies x gives us minus 3x, and minus 3 multiplies 5 gives us minus of 15 is equal to 0. So here you have to be very careful when you are dealing with positive and negative, specifically when you're also multiplying. So here we can just add what we have here, which means that y squared minus 6y plus 2y gives us minus of 4y minus 12. So we have plus x squared here, and plus 5x minus 3x gives us positive of 2x, and you have our minus 15 as well, which is equal to 0. So we can write them as such, that is s squared plus y squared minus, so I think, so we continue, so you have s squared plus y squared followed by 2x before that of y, so which means you have minus 4y here, and then we can see that there is minus 12 and there is minus of 15, which is equal to 0. So once we have this, it's just by adding minus 12 and minus 15, that gives us minus of 27. We equate to 0, and also repeat that of s squared plus y squared plus of 2x minus 4y, and then we have our existing minus 27, which is equal to 0. So for this example, our final answer is s squared plus y squared plus 2x minus 4y minus 27, which is equal to 0. So this ends today's video and our set of examples for today. And so thanks for watching. Kindly like, comment, subscribe, and share. Remember that this is Bakumat, thinking beyond infinity.